Hello, hello. So today I'm going to be talking about open versus closed source, which is a pretty big deal these days because as everyone's pushing towards production LLMs, we don't want full security vulnerabilities everywhere we go. And a lot of people in here work for companies that we definitely don't want security vulnerabilities. So open source has been a really big deal for a pretty long time. Most of everything that exists on the internet is originally from an open source product or relies on an open source product. Oh, I have a clicker. Okay, it would work. But it has also allowed us to make the world a place of transparency. So you can see everything in an open source product of how it functions and what it relies on. It comes with a lot of benefits, as I said before, transparency of data, but also the idea that a community can support the contribution and development of your product, which, benefits everyone. And you can also add and pull down versions of software for yourself. Any fellow developers in the crowd also have probably heard of Cursor. If you've used it before, you've probably realized it's just a fork of VS Code with some very neat little AI features added to it. Now, closed source, on the other hand, refers to software that is restricted. Typically, this is for corporations or people that want to protect, monetize, or also hide their software from competitors. And this typically happens through source control features that are managed in an enterprise unit like GitHub or Bitbucket that's self-hosted. It also comes with a lot of benefits. Some people may have heard of the XZ attack, which is an attack that almost happened, luckily didn't, because some very smart guy from Microsoft realized that his login was half a second slow, because of course he did. And it was essentially that a compression library that a lot of Linux machines that power the internet rely on had some guy contributing and built up a rapport with the code owner of the repository that was doing the compression, and then out of nowhere started opening an SSH encrypted backdoor to all of those pieces of transmitted compressed files. So if we think about the fact that everything transferred through the internet could have hypothetically been sent to whoever this guy was, wherever he wanted it to go. Luckily, that was turned off before it actually happened, but very close one. So that's kind of a big issue with closed source, is that if the code isn't being reviewed directly, then you don't really know what it's going to do otherwise. You also have full internal ownership and responsibility. We have it a lot in options where sometimes Microsoft will change something, and it kind of means that we have to wait for them to either get back to us or tell us what's actually wrong. But if you have full ownership of the code, you can change it yourself. You don't have to wait for anyone else, basically. You also don't need to host things yourself if you're using closed source artificial intelligence. It's all running on some other company's servers who have data centers and rooms with a load of very smart people making sure they're always up, or trying to at least. And also there's a lot of detailed documentation for closed source products. So at the minute, the most popular open source artificial intelligence systems are the Llama family, which a lot of people have probably heard of, from Meta. There's also Mixtral, that is produced by Mistral. Bloom from Big Science is a huge LLM system that covers a lot of coherent human languages, but also programming languages. And also Grok from X, which a lot of people have heard of. It gives full control to everyone who wants to host their model to fine-tune it on their own weights, host it on their own infrastructure, and privatize the environment that it's actually running in. It also means that if you were to run Llama on your own infrastructure, it'd be fully privatized, but also you can decentralize technology that at the minute a lot of people see as being centralized to big companies like OpenAI. So there's a lot of cool tools out there that make running LLMs on high-performance chips a lot easier. Some of these are stuff like TensorRT and Private GPT. TensorRT is just a bunch of SDKs and APIs that make running LLMs on NVIDIA chips a lot easier. And also it's able to speed up inference by 36 times, which is kind of neat. And Private GPT allows for retrieval augmented generation, which, if anyone isn't familiar with, it's basically making your models pull in information from a live or real-time context source and augmenting the output of them through that. We're also seeing something called Mojo, which is an AI programming language. And these might be actually something that we'll be more familiar with in the future. But this is essentially Python syntax with C++ and ScaleRC performance, which, if anyone knows what I just said, then they'll realize that that's pretty insane, because Python itself is typically regarded as kind of a slow language. It uses this thing called an interpreter. It basically has to figure out what you're writing before it then can actually run it. But Mojo acts as an SDK. it says, okay, every piece of Python code that is written will then be directly compiled directly to C++, which, if we're familiar with C++, it's really, really fast. So this is from Mojo's website, but running the Mandelbrot algorithm is actually 68,000 times faster than Python is at running the Mandelbrot algorithm. So something that would take you 1,027 seconds in regular standard Python will take you 0.03 seconds in Mojo. So these are probably going to become, well, they're only going to become better and faster and more efficient. So ideally, this could provide something that people who are mounting and running their own open source models can actually build in. There's also a huge open source community. As I said before, contribution is a huge part of why it still exists. Stuff like Hugging Face and Kaggle allow for developers who are hobbyists to pull in data sets that are Stanford University quality and run them locally on their own machines, or pull in stuff like Google Colab. All of these systems are supported by a community of people, and they're all free and easy to access. So there's a lot out there. As I mentioned down at the bottom of that slide as well, Google Colab is a fantastic tool. You essentially get free access to tensor processing units, which is Google's infrastructure. And if anyone has actually noticed about Mojo, I don't know if anyone in the room knows what Mojo is, but the guy who built this used to be head of Tensor at Google and like full self-driving head at Tesla and stuff. So he's a pretty important dude. But so at the minute, closed source AI is primarily hosted by about 4 companies, technically 3, but one of them piggybacks off the other one. GPT families, DALL-E, Whisper, those OpenAI models. Whisper is actually open source technically, but the idea that OpenAI have audio models and language models that are all running on their own data centers and systems means that we don't actually know where data you're sending to companies like this is going. So there's kind of an unverifiable claim there. They might say, oh, if you send data to the API, we're not going to train models on it, but it's really good data, and it's a lot of very big amounts of data that's very reliant on how the models could be used. So there's kind of no reason they wouldn't. But once again, since there's not a lot of regulation in place for artificial intelligence at the minute, it's kind of easy to just blindly follow that claim, but to each their own. People have probably also heard of Claude. Claude is currently regarded as being one of the best programming models in the artificial intelligence space. And then also Gemini from Google, which is kind of piggybacking off the Bard family of stuff. They're very easily used by hobbyist developers, and since they're closed source and OpenAI manage everything, none of the code is directly changing on their systems. So the documentation is really good for OpenAI models, but it's kind of scarily good in the fact that it's way easier to use it than hosting your own LLM. So there's a lot of benefits. Obviously, the cost of entry to get into closed source OpenAI is like through the floor. It's great, but also you can kind of drive innovation through these companies competing with each other. All of them are trying to be the best AI, and if they're the best AI, then everyone's going to use them and everyone's going to pay them money. So the only way to truly drive innovation seems to be competition in a space like this, and they're all kind of running towards it, which means from a consumer aspect and from a business aspect, we get better technology to use, but at the cost of it being closed source and unverifiable for the time being. So at the minute, Options IT are currently leveraging our NVIDIA chips that we have running in our New York data center. We have 2 H100s running Llama. And we also have a platform called Horizon. So technically, some people may consider this as closed source AI, but we actually have full transparency of the data flow. So we can provide the Horizon API that will let you use Llama right now, and you can have capped compute directly from any machine. You don't need to work for Options. You could just be a regular person, sign in with a Google account, spin up a Linux machine, spin up a Windows machine, kind of any of it works. We have Langflow instances as well. You can build a full artificial intelligence system on our platform, run it on our infrastructure, and you have full verifiable claims of exactly where that data is going. And since we're the developers of it, you can get directly in contact with Options, and someone will pick up the phone in about 5 seconds. So I can leave the QR code on the screen, sure, but that's all I have to say. Hope everyone enjoyed it a bit. Thank you.